न तू ज़मीं के लिए है न आसमां के लिए, जहां है तेरे लिए तू नहीं जहां के लिए। मकाम परवरिश ओ लाला है ये चमन, मकाम परवरिश ओ लाला है ये चमन, न सैर गुल के लिए है न आशियां के लिए, न सैर गुल के लिए है न आशियां के लिए। Assalamu alaikum. Here is Rabia Basri, an entomologist, an agriculturist, a thinker and a writer. So welcome to my channel, that is Rabba Science Talk. So as I have started with the lines of Allama Iqbal, actually he was a very great thinker and a great scholar. उन्होंने बहुत ही अपने सारे ज़माने के लिए फ़िक्र फ़न का मुज़ाहिरा किया है अपनी शायरी में, अपनी पोइट्रीज़ में। उसी से मुतालिक एक टॉपिक मैं आज जिसको यहाँ पर प्रेजेंट करना चाह रही हूँ, जो कि अभी पीछे ही अर्थ डे गुजरा है, जिसको हम 22 अप्रैल को सेलिब्रेट करते हैं। As we are already facing a huge crisis among the human beings regarding the corona disease, and we are watching that and we are witnessing recently we have witnessed that a lack of oxygen is there. So this is one of the those alarming situations which we have been told earlier that these kind of situations may occur in future. So not only this this is a huge crisis, however, so but in future we will face the crisis regarding the this year rising of the sea level, and also the melting of the glaciers because of the climate change. So lot of processes, lot of series of this events are taking place simultaneously, which are affecting our climate, and ultimately it is affecting the biodiversity of our earth, right? So not only one component, but a lot of components, and from different industries, from different enterprises are involved in this, and we and every individual is involved in this or contributing in the change of the climate. So as I am connected with the branch of a science which is dealing with the agriculture sector, therefore I want to discuss the prospects of Earth Day from the point of view of agriculture. So this year a theme for the Earth Day is Restore Our Earth. This is the theme for Earth Day 2021. जो हमारा अर्थ डे 2021 का थीम है वो है Restore Our Earth. It means that how we can restore the natural resources which are essential for the life of human being as well as for other living beings also, which are the part of this ecosystem. So the Earth Day is being celebrated since 1970 on 22nd April. So there are 192 countries which are participating in the activities regarding the conservation, regarding other activities of the earth to save the earth each year. So the major issues are climate and environmental literacy, climate restoration technologies, and equity and environmental justice. So first one, that is climate and environmental literacy. It means we have to be aware and about the environmental issues and the climate changes which are occurring day by day, and which are the consequences of our activities, our enterprises, the output or the byproduct of our enterprises. Next is the climate restoration technologies, how we can restore our climate which has been already spoiled by us, how we can, or by using which technologies we can restore those resources and we can save our climate or save our earth. and the third one is the equity and environmental justice. So how we have to find those methods which can be justified with the use of natural resources. This is the data of global CO2 emission, that is carbon dioxide emissions in different countries from the different industrial processes as per the data of 2014. So as per this, China is on the top. It is emitting 30% carbon dioxide. United States is emitting 15% carbon dioxide. European Union is emitting near about 9%, and India is on fourth position with the emission of 7% carbon dioxide. Then Russian Federation, Japan and other countries are there, which are total means in total they are emitting near about 30% carbon dioxide. So my concern is that how this agriculture is contributing into the this environmental issues and environmental degradation or climate change. So there are many causes. Deforestation is one of them. Then biodiversity loss of is the cause of another, consequences of another activities. Then genetic engineering, irrigation, problems associated with the irrigation, pollutants which are emitting from the agricultural fields like methane production from the rice field, soil degradation. There are many causes which are leading to the soil degradation. Then agricultural waste and crop residue, that is very much and very important and major problem in the agriculture. Their disposal, their means we can reuse, recycle those crop residue or we can use it in other for the purpose of biofuels in many other industries. So here we can see statistically that how much this year agriculture or forestry is contributing into the global greenhouse gas emissions. So here are the data of about various sectors, but here agriculture is emitting near about 24% of this year global greenhouse gas. So as per this pie chart, we can see that most of all the major contribution is of carbon dioxide among all greenhouse gases. We can see here 65% carbon dioxide is emitting from the fossil fuels and industrial processes, whereas this carbon dioxide which is emitting from or the byproduct of forestry and other or land uses. Other than carbon dioxide, methane has a major contribution in this of 16%, then nitrous oxide, then other gases are of 2%. So this is the data according to the Intergovernmental Panel on Climate Change. It is a United Nations body which is assessing the science related to climate change. So as we have seen, methane has a contribution of about 16% among all the major global greenhouse gases. So here the anthropogenic methane emission, the largest source for anthropogenic methane emission is agriculture. So it is responsible for around a quarter of the total, that is closely followed by the energy sector, which includes emissions from coal, oil, natural gases and biofuels. So this methane is producing from the terminal step of the anaerobic breakdown of the organic matter in wetland rice soils. So wetland जहाँ पर तरी रहती है, नमी रहती है, जो soils waterlogged होती हैं. So you have noticed that in rice fields, the field is always this is waterlogged. Means water is filled in those kind of fields, in rice fields. So from that this organic matter, the breakdown of organic matter is occurring in those fields, and anaerobic reaction is taking place. Means in the absence of oxygen, these reactions are taking place, and due to those reactions, this methane is producing. So some other volatile acids are also producing in those kind of reactions, which are contributing to our atmosphere. So as per my knowledge, or as I have studied about this, the cultivation of rice, so we can follow the dry direct seedling. There are two kind of this dry and wet. So we can go for the dry direct seeding. Not seedling, but the seeding means before the transplanting of rice, we have to prepare the nursery. But in this, we can go for direct seeding. In this, we can follow the broadcasting process, or we can go for the drilling process. So there are certain parameters, certain rates of seeds are there. So we can follow accordingly. So as in a direct seeding through broadcasting, we need about 60 to 80 kg of seeds per hectare. While in drilling, we can we have to have 80 to 100 kg of seeds per hectare. You can see here broadcasting is a simple process as farmers used to broadcast the fertilizer also. So this is the broadcasting method you can see here. So next is the drilling method through the happy seeder. So these are the pictures showing the same process. So dibbling is a method where we can just create scoop the surface and with where this on the mountain slopes where we cannot go for deploying or harrowing very easily. It is very difficult in those areas, so we can go for the dibbling in those areas. So previous methods are for the dry direct seeding. Now here is there are two methods for the wet direct seeding. Broadcasting, again broadcasting you can do in wet direct seeding, and also you can go for the drum seeding. So it can be operated on a well-level, smooth seed beds or the wet seed beds, and you can prepare 80 kg of pre-germinating seeds per hectare. So next what we can do, we can this year go for the integrated farming system. Here this is the example of integrated farming system: rice, duck, azolla and fish cultivation. So this method was invented by the Dr. Takao Funo from the Japan. He is a Japanese farmer as well as the entrepreneur. So he developed a rice, duck, azolla and fish cultivation bioecosystem. So this method can reduce the use of the fertilizer, herbicides and pesticides. Here what we are doing, that we are using the same piece of land for all these kind of cultivation, for the rice cultivation, for the duck cultivation, for the fish cultivation, the same piece of land. So we are using it for more in a more productive way, as well as we are also cultivating this azolla, which is a biofertilizer. So this fulfill the need of the fertilizer in the same field. So Dr. Takao has also written a book, The Power of Duck. In this book, he has mentioned the methods which are associated with this cultivation method. So this approach is becoming very popular in Southeast Asia, which is boosting the farmers' income as well as also reducing the environmental negative impact on the environment, and also improving food security. In this picture we can see ducks are present in the rice field. They are swimming in between the rows of the rice plantings. So as per the Takao, 1,60,000 US dollars per year are generating from the 3.2 hectare. More than 75,000 farmers from different countries, Japan, Korea, China, Vietnam, Philippines, etc., are following this integrated farming system for generating the good income. Golden apple snail is a major problem according to the Takao. It is feeding on the azolla. So golden apple snail is detrimental for this integrated farming system. Here you can see the growth of the azolla, And this is the golden apple snail, which is a threat to the ecosystem. This kind of integrated farming system. It was a different thing that this golden apple snail was person produced for its cultivation, but for this in this case, in this integrated farming system, it is proving as a threat. And here you can see it is feeding upon this azula. So we have seen a solution for the this your rice ecosystem, and how we can use that same field for different purposes and manage other things, and we can reduce methane production. And here the another major problem in agriculture is the crop residue, which is a major contributor in rising the level of this greenhouse gases in the environment, because farmer used to burn these crop residue itself in the field. So you can see here, according to the ICR 2012 data, it is estimated approximately about 500 to 550 metric tons of crop residues which are produced per year in our country. So these crop residues we can use in the form of the animal feeding, soil mulching, biomanure, or for thatching of rural homes. It is a different thing that in today's rural culture, there are all cemented buildings are there. No one has this thatch roofs, which was found in older or the uh, before 2 decades. We can also use crop residue as a fuel for domestic and industrial purposes. But despite of all these uses, this crop residue is a major problem. Why it is a major problem? Are those uses enough to get rid of the crop residue? No, not at all, because it is the problem regarding this your crop residue is existing with all these alternative uses. Why it is there? So a large portion of these crop residues are burned by the farmer on the farm field itself. So what are the problems associated with this? Shortage of human labor is one of the problem. So because the labor is migrating to the urban areas for different kind of labor, not in the farming means not on farming fields, but they are migrating for other jobs which are present in the urban areas. Next is the high cost of removing the crop residues by conventional method, because human labor is short. So harvesting and threshing of seeded crops are also becoming more mechanized from in the recent times, which is leading to these residues remain in the field. They are not cutting these straws of the seeded crops from the ground level. Residues of which crops are typically burned on farm across different states of the country are rice, wheat, cotton, maize, millets, sugarcane, jute, rapeseed, mustard, and groundnut, etc. Here you can see, or you can imagine that when the farms, this crop residues are burned in the farms, how much destruction it will cause to the environment. And we have also witnessed in last years that how much this burning of the rice crop residue has revealed hazards to our environment. We have seen that smog-like conditions appeared in Delhi region and also in Uttar Pradesh, Punjab, Haryana region because of this burning of the crop residue on the field. Here are the negative effects of residue burning, or the detrimental effects of residue burning, which includes emission of greenhouse gases, release of soot particles, causing smog. Soot particles are very small black particles which come into the air from the this your straw burning. And next one is health hazards to human, animals, and birds. Loss of biodiversity, loss of carbon, loss of soil flora and fauna, so many microorganisms which are beneficial for our soil health, soil quality, that are also being reducing because of the burning of the residue on the same farm field. So deterioration of soil occurs, fertility of soil also reduces because this microflora or the fauna present in the soil helps in the organic this decomposition of organic matter, dead and decay matter. It increases the humus content of the soil and also this carbon content of the soil. Next is loss of plant nutrients or biodiversity. These all are contributing in the detrimental or the hazardous effect of the residue burning to our agricultural ecosystem as well as overall global warming. This pie chart is showing the distribution of the crop residue as a soil used as fodder, crop used as cooking fuel, used as compost for the formation of the compost, and also incorporated in soil and thrown away, which are thrown away, just do not use in any kind of useful application, and the which is burn open in this your field. It is 82% which is burned open in field. How much harmful the effects can be? Here we can see among all the crop residue, cereal crop residue is about 58%, from the sugar crop it is 2%, from pulses it is 2%, and from fiber crops it is 23%, from oilseed crop it is 7%, and from other crops it is 8%. These are the data showing how much gases are producing from which crop and what is the contribution or decomposition of particular gases among all the harmful greenhouse gases. If we will see the among the crops, so rice is emitting more this 40% of greenhouse gases, and among the gases this carbon monoxide is for 65.98%. Here you can see according to the IPCC and other two authors, we can see that this data among the states of India, Uttar Pradesh is having more vegetation cover area than the West Bengal, then Punjab, then Gujarat, Maharashtra, and accordingly it is varying. So the question is how we can utilize the crop residue for different purposes. So we can use it as a livestock feed and also for the compost, preparing the compost, and as energy sources, also as biomethanation process, in biomethanation process, gasification, producing this biocharcoal. For mulching we can use it, for animal bedding we can use it. So the biocharcoal production can be processed through slow pyrolysis, fast pyrolysis, gasification and clarification. Some limitations and uncertainties are there, but we can use this biocharcoal for the soil improvement, for soil remediation. We can go for the water treatment, carbon sequestration, and greenhouse gas emission mitigation. For these purposes, we can this year apply biocharcoal. So here this picture is showing the growing of horse gram during post-rainy season with maize residues and conservation agriculture in rain-fed conditions. Rain-fed where not sufficient water is available for the irrigation, and this is the thermal plant of Kalpatru Power Transmission Limited in Tonk district of Rajasthan. Here we can use happy seeder for direct drilling of seeds in the presence of surface residues. And this is a low cost pyrolysis clean plant in the IRI, and this picture has been taken from the IRI professionals. I have taken from that. Here this is the sketch of this biocharcoal production, showing the pathway for the production of biomass of this biocharcoal from the biomass. So these were those certain criteria, those certain means problems which I have addressed, and as per my means investigation or the knowledge, I have find those kind of substitutions for these problems. We can combat these issues by using these certain ideas and technologies. We can apply it in our day-to-day life for means who are involved in the practices of agriculture. So I suggest them कि आप लोग इन सारे प्रैक्टिसेस को हो सके तो अप्लाई कीजिए, चाहे छोटे लेवल पर कर रहे हैं या बड़े लेवल पर कर रहे हैं. For scientific community also we can do a lot in these areas, and we can find the loopholes present in these areas and what difficulties these farmers are facing. So we have to find out those difficulties, those difficult areas we have to find and work upon it. So these were my findings, these are suggestions. If you have any suggestion or you have any idea or you have any in your view, if you have any this major problem related with the agriculture which we are facing during this cultivation of the crop, or any other practices which are affecting our environment directly or indirectly, means use of pesticides are there, chemical pesticides, but other than that, or during this the practice while we are practicing these application of pesticides and fertilizers, other than this, if we are facing or if we found anything regarding that, we have to address it and we have to work upon that. If you have any idea, you can write down in the comment box, and definitely you tell me about this video. Thank you so much. I am Rabia Basri signing off till the next video. Thank you.